Hello and welcome to Fouraye Education. I will be covering financial mathematics, specifically stochastic calculus, but more like pre-stochastic calculus, as we won't be doing calculus. We'll be looking at the concepts of stochastic calculus, such as the martingales, Markov processes, and random walks, which will later become Brownian motion, etc., etc. Now, in this episode, we'll be looking at the no-arbitrage one-period binomial pricing model. The no-arbitrage one-period binomial pricing model. Asset pricing model. So we assume the asset is a stock to make it easy. So we have our stock price at time 0, which can go two ways at time 1. It either goes up or goes down. We assume that we flip a coin, which does not have to be fair. It can have probabilities P for going up and Q for going down. Q would be 1 minus P and P would be 1 minus Q. These do not have to be equal to each other. If P is 0.7, Q can be 0.3, for example. Now, the notation we use in the one-period binomial model is that if it goes up, we use H signifying heads, T signifying tails. Now, another concept we need to understand is the up and down factor. The up factor is the value the stock at a previous time, in this case time 0, is multiplied by when the coin rolls heads, and the down factor is the value which the stock is multiplied by when it goes down. So this is what we have. But keep in mind, this is a no arbitrage model. So now we'll get into the most important part, which is what arbitrage is and how to exclude it out of our model, so our model is more usable to price assets and financial derivatives. Now, the concept of the down and up factors are very important because we will introduce in the concept of R, which is the money market interest rate. In this case, we assume we have a asset market, in this case the stock market. And again, this would be shown as such. Now, if we invest $1 into the money market, at time 1, it will pay us 1 plus R. If we borrow 1, at time 1, we have to pay minus 1 minus R. Now, you can play around with R and D and U ratios so that you can eventually have no risk at all. So you could borrow money or invest in such a way that there is no risk, making this model, or at least do that in this model, making this model unusable to model different derivatives. So we need to exclude arbitrage. In order to exclude arbitrage, there's this rule, which is shown right here. Now, these are not bigger than or equal to for a reason. Now, we'll look at the cases where these are bigger than or equal to. Assume we have our stock market, SO, S1H, and S1T. If we borrow money, let's say we borrow $1 and buy the stock, we have $1 of debt towards the money market, which will be $1 plus R of debt. Now in this case, we are assuming that U is bigger than D is bigger than or equal to 1 plus R. So in this case, if D is equal to 1 plus R, then S0 times D would be S0 times 1 plus R, which is 1 times 1 plus R, which means you could sell the stock during this time to pay off your debt, and if it goes up, you would get profit, hence being bigger. The other case, which is the case of U bigger than or equal to U bigger than or equal to 1 plus R bigger than or equal to D bigger than 0. Oops, this is bigger than. Have again the market. In this case, this is again US0, DS0. So in this case, we start short. So we borrow a stock and we short sell for $1. And when the price goes up, and we invest this into the money market, so we get 1 plus R dollars during time 1. If the stock goes up to 1 plus R dollars because U is equal to 1 plus R, then we could use this money to buy that, hence having no loss. And if it goes down, we could buy it for a less amount and pocket the change. And that is basically the concept of arbitrage, and that is the no arbitrage one period binomial pricing model, and that's it.